Hello everyone. In this chapter, we are going to study the Laplace transform. First section is the Laplace transform. We are going to define the Laplace transforms. Second section is the solving linear ordinary differential equations. Third section is the operational properties. In the first section, the Laplace transforms. Laplace transform of a function of f is defined by these equations. So using these integral forms, we convert a function into another form of functions by multiplying the exponential minus st integrate with respect to t. So resulting function is a function of s. Laplace transform of the ft. Sometimes we use the upper case of the f to distinguish. Lower case of the f is before Laplace transform, and the capital F is after Laplace transform. Then Laplace transform of this new function is a function of s, because the integrals about the t. And the lower limit is 0, upper limit is infinities. And I'd like to show you the examples. Laplace transform of the 1. Then you can just substitute 1 into the f. So in this case, ft is 1. Then you can integrate this one. It becomes minus 1 over s exponential minus st. T is starting from 0 to the t equal infinities. If you substitute t equal infinities, you need to add additional information of the s is a positive quantities. Because of the exponential minus positive times the infinity becomes 0. So upper limit, if you substitute the value of the t is approaching the infinities, this approach to the 0. If you substitute the t equals 0, it becomes 1 over s. So Laplace transform of 1 is equal to the 1 over s. And also once we define the Laplace transforms, we'd like to introduce the inverse Laplace transforms. When the Laplace transform of a function of f is defined this way, then Laplace transform is a function of s. The inverse Laplace transform is defined as L minus 1 is the inverse Laplace transform. So if you apply the inverse Laplace transform to the Laplace transform, then it's returned to the original function of the lower case of the f as a function of t. So to find out inverse Laplace transforms, find the pair of the Laplace transforms. So Laplace transform of the 1 is equal to the 1 over s. The inverse Laplace transform of the 1 over s becomes equal to the 1. In the case of the Laplace transform of the 1s, you can calculate from the left to the right. But in the case of the inverse Laplace transform, you find the right to the left. And also the Laplace transform of the exponential at can be calculated 1 over s minus s. So we are going to solve this Laplace transform of the exponential at in the practice. So check the practice carefully. Then we use this equation to find out the inverse Laplace transform of the 1 over s minus a. It returns to the original function of the exponential at. Then I'd like to explain the transforms of derivatives. Laplace transform of a derivative of a function f is defined. So instead of f, you can substitute f primes because of the Laplace transform derivative of a function f. Then we can use the integration by parts we applied. Then not derivative of f and exponential minus st. So plus derivative of the exponential minus st produce the minus s. Minus s becomes a positive s. And the exponential minus st ft dt. And then if you substitute t equal infinities, this is t equal infinities, the exponential st is approaching to the 0, so it's going to be 0. So if you substitute t equals 0, it becomes negative f0. So from the first terms, you have a single term of the negative f0. And times s. So if you look at this is actually equal to the definition of the Laplace transform. So s Laplace transform of the f. Laplace transform of a derivative of a function of f is a minus f0 plus s times Laplace transform of the function of f. Similarly, we obtain the Laplace transform of a second derivative of a function. So we just substitute this one. Then integration by part. By parts, we applied again. Then exponential minus st f prime t plus s blah blah. Then this is equal to the Laplace transform of the f prime t. So we come to these equations. Then we substitute Laplace transform the f primes using the result from the first terms. This becomes minus f0 plus s f s. It becomes minus f prime 0 minus s f0 plus s square capital Fs. This is Laplace transform of the function of f. Okay, so in this session, I introduced the definition of a Laplace transform and also inverse of a Laplace transform. And also I showed the Laplace transform of a derivative of a function of f and also the higher derivative of a function of f. This is the end of the first session.